In the last class, we looked at the architecture of Kubernetes and 80,000. The control plane, the worker nodes, all the moving parts that make a cluster work. That gave you the map. But you cannot truly learn Kubernetes from a map any more than you can learn to drive by reading about a car. You learn it by getting your hands on a real cluster, deploying something, watching it run, deliberately breaking it, and figuring out how to bring it back. For that, you need a cluster of your very own, an 8024, a lab and 8024, and the wonderful news is that getting one has never been easier. Today, we will walk through every option, from a cluster that spins up on your laptop with a single command, all the way to a full production-grade cluster running in the cloud. And by the end, you will know exactly which one to pick for where you are right now. So let us build you a place to practice. Here is what we will understand today. First, why having your own lab is not optional but essential. Second, the two most popular local tools, CKAD and Minikube. Third, kubeadm, for building a real cluster by hand. Fourth, manage Kubernetes from the cloud providers. Fifth, kubectl, the one remote control you will use for all of them. And sixth, how to choose the right option for your goal today. Let us begin. Let us start with why this matters so much. Because it is tempting to think you can learn Kubernetes by watching videos and reading documentation. You cannot N82 at least not really. Kubernetes is a hands-on system. Its concepts only click when you have typed the commands yourself, watched a deployment rollout in front of you, seen a pod crash and restart, and traced why something would not schedule. The understanding lives in your fingers and in the mistakes you make, not just in your head. Reading about it gives you words, doing it gives you knowledge. And the single most valuable thing about your own lab is that it is yours to destroy. You can deploy something badly, delete the wrong thing, misconfigure a network, and it does not matter at all. An 8 to fall, nobody is affected, no real users go down, no bill spirals. That freedom to break things fearlessly is exactly what accelerates learning. On a production system, you are cautious. On your own throwaway cluster, you can be bold. So the goal for today is simply this: get you a cluster you own and can experiment on freely. Everything else in this course, an 8212, pods, services, deployments, troubleshooting, and 8212 assumes you have somewhere to try it out. This class makes sure you do. So the takeaway: Kubernetes is learned by doing, and 8212, deploying, breaking, and fixing things, and 8212. So you need a cluster of your own that you are completely free to destroy and rebuild. Before the details, let us lay out the whole landscape, because there are really three families of ways to get a cluster, and it helps to see them as a ladder from easiest to most realistic. At the easy end are the local tools. These run an entire Kubernetes cluster right on your own laptop, usually in minutes and completely free. They are simplified and small, but they behave enough like the real thing to learn almost everything. This is where nearly everyone should start. In the middle sits kubeadm. This is the official tool for building a real, production-style cluster by hand, wiring the components together yourself across one or more machines. It is more effort, but it takes you much closer to how a genuine cluster is actually assembled. At the realistic end is managed Kubernetes. Here, a cloud provider runs the difficult, critical parts of the cluster for you, and you just use it. This is what most companies run in production because it removes the hardest operational burden. So the takeaway: there are three routes to a cluster: an 8112, a free local one on your laptop, a hand-built real one with kubeadm, and a managed one in the cloud, and 8112, forming a ladder from easiest to most production-like. Let us start where you actually should, an 8212 with the two most popular local tools, CKAD and Minikube. Both give you a real Kubernetes cluster on your own machine, and both are excellent with slightly different flavors. CKAD stands for Kubernetes in Docker, and that name tells you exactly how it works. It runs the cluster's nodes as Docker containers on your laptop. Because containers start almost instantly, CKAD is extremely fast to create and tear down, which makes it a favorite for automated testing and for spinning up a fresh cluster again and again. Minikube is the friendly, beginner-oriented option. It sets up a single node cluster and comes with a rich set of add-ons you can switch on: an A212, a dashboard, storage, ingress, and A212 with simple commands. It is designed to be approachable, and it is often the very first cluster a newcomer runs. The honest truth is that for learning, you cannot go wrong with either. Both give you a genuine, throwaway Kubernetes cluster in a few minutes on hardware you already own at zero cost. Pick whichever you find first in a tutorial and start. You can always try the other later. The point is to have a cluster today. So the takeaway: Kind runs Kubernetes inside Docker containers and is wonderfully fast, while Minikube is a friendly single-node cluster with easy add-ons and 8200 tool fall, and both give you a free, throwaway local cluster that is perfect for learning. Once you've played with a local cluster and want to go deeper, an 8025 to understand how a cluster is really put together, an 8025, the next step is kubeadm. So what is it? kubeadm is the official Kubernetes project tool for bootstrapping a real cluster. Rather than hiding everything behind a single magic command, it walks you through initializing a control plane node and then joining worker nodes to it, producing a genuine multi-node cluster that closely mirrors a production setup. And here is why it is worth the extra effort: because you assemble the pieces yourself. kubeadm teaches you how the cluster actually works. You see the control plane come up, you handle the certificates and the join tokens, you install the networking layer with your own hands. The abstractions that a local tool or a managed service quietly handle for you are suddenly visible and yours to configure. For anyone preparing for a serious certification or who simply wants to truly understand the machine, this hands-on assembly is invaluable. The trade-off is that it is more work and less forgiving than the local tools and 82-fold. But that friction is the point. You are trading convenience for understanding, and for building real operational skill, that is a very good trade. So the takeaway: kubeadm is the official tool to bootstrap a real, production-style cluster by hand. And because you wire the pieces together yourself, it is the best way to truly learn how Kubernetes works underneath. Now, the option that most real companies actually use in production, and A202 managed Kubernetes, offered by the big cloud providers. Every major cloud has one. On Amazon, it is EKS. On Google, it is GKE. On Microsoft Azure, it is EKS. The names differ, but the idea is identical: an A212, and it is a powerful one. With a managed service, the cloud provider runs a control plane for you and 82 pull, the master components that are the hardest and most critical part of a cluster to operate correctly. They keep it available, they patch it, they handle its failures. You simply ask for a cluster, and a real one appears, with the difficult operational burden lifted off your shoulders. You focus on your applications, they focus on keeping Kubernetes itself healthy. The result is that you get a genuine, production-grade cluster with a fraction of the operational effort. This is exactly why managed Kubernetes dominates in industry. Running the control plane yourself, reliably around the clock, is genuinely hard, and most teams would rather pay the provider to do it and spend their own time on their software. So the takeaway: managed services from the big clouds and A212, Amazon, Google, and Microsoft Azure, and A212 run the difficult control plane for you, so you get a real, production-grade cluster with far less operational work. Whichever of those clusters you end up with, there is one tool that ties them all together, and it is the tool you will use more than any other: an 8200 kubectl. Kubectl is the command line interface for Kubernetes. It is how you talk to a cluster, how you deploy an application, list what is running, inspect a pod, read logs, and fix problems. Every instruction you give a cluster day to day goes through kubectl. And here is the beautiful part, the part that makes all of today's options feel like one skill instead of many. Kubectl works exactly the same way against every kind of cluster. The commands you learn on a tiny Minikube cluster on your laptop are the identical commands you will use against a giant managed cluster in production. It does not care whether the cluster is local, hand-built, or in the cloud and 8-hour tool. It just talks to whatever cluster you point it at. This is enormously reassuring for a learner. It means the time you invest now, practicing on a free local cluster, transfers completely to the real world. There is no separate toy scale and real scale and 8-1-2 all. There is just kube control, and you are building the real thing from day one. So the takeaway, kube control is the one command line remote you use to talk to any cluster, local or cloud. So the skill you build on a free laptop cluster transfers directly to production and 8-1-2 valve. Learn it once, use it everywhere. Let us weigh the two ends of the spectrum against each other honestly and 8-Hadoop local clusters versus managed ones and 8-Hadoop because each is the right choice at a different moment. Local clusters like KAD and Minikube are free, instant, and throwaway. You can create one in minutes, wreck it without a care, and delete it when you are done, all at no cost. Their limitation is that they are simplified and 85-2, a single node or a handful. Running on your laptop and 85-2, so they are not identical to a large, real deployment. But for learning almost every concept, that difference rarely matters. Managed clusters are real and production-like. They give you multiple genuine nodes, real networking, real scale, and behave the way a true production system does. The catch is that they cost money, because you are renting real cloud machines that run around the clock, and it is easy to forget one and rack up a bill. So the guidance is clear and matches how professionals actually work, learn, and experiment on free local clusters where mistakes are cheap and iteration is instant, and move to a managed cluster when you genuinely need it to be real and 80-112 for production, or for testing something that only shows up at real scale. So the takeaway, local clusters are free, instant, and throwaway but simplified, while managed clusters are real and production-like but cost money and 8-1-2 fall, so learn on local and move to managed only when it truly must be real. Let us turn all of that into a simple decision so you know exactly what to do when you close this video. Match the tool to your goal. If you are just learning an 8-102 fall, and if you are watching this, you almost certainly are an 8-102 fall, use KAD or Minikube. A free local cluster on your laptop is by far the fastest, cheapest way to start practicing, and it is genuinely all you need for the great majority of this course. If your goal is to understand the internals deeply and 8-1-2-8-wall, perhaps you are chasing a serious certification, or you simply want to know how the machine is built and 8-1-2-8-wall, then set up a cluster by hand with kubeadm. The extra effort is exactly what teaches you how the pieces fit together. And if you need to run real workloads for a real product with real users, reach for a managed service from Amazon, Google, or Azure, and let the cloud carry the operational weight. The key reassurance is that you do not have to decide forever today and 8-200 and the I-200A. Start local and free right now and graduate to the cloud whenever you are ready. So the takeaway, pick by your goal and 84-2, KAD or Minikube when you are learning, kubeadm when you want to understand the internals, and a managed service for real production workloads, and 84 duos and 84 dudos and 84 dudos, because you can always move up later. Let us finish with the concrete first steps, the exact things to do right after this class to have a working lab. First, install either KAD or Minikube. Follow the quick start guide, run the create command, and within minutes, you will have a real Kubernetes cluster running on your own laptop for free. That single step removes every excuse not to practice. Second, install kubectl, the remote control we talked about. This is the tool you will use for the rest of your Kubernetes life against every cluster you ever touch. So getting it set up now is time very well spent. And third, and 8012y, the most important step, and 8012y, actually use it. Deploy something simple, then poke at it, delete a pod, and watch it come back, change something, and see what happens, break it on purpose, and fix it. That loop of deploy, break, and fix is where real understanding is forged, far more than any amount of reading. So the takeaway, install KAD or Minikube for a free local cluster, install kubectl to control it, and then deploy, break, and fix things in A212. Because hands-on practice on your own cluster is the entire point of having a lab. Let us gather the whole class in one breath. A lab is essential because you learn Kubernetes by deploying, breaking, and fixing on a cluster you own. Kind and Minikube give you a free, throwaway cluster right on your own laptop. kubeadm builds a real production-style cluster by hand and is the best way to learn the internals. Managed Kubernetes from Amazon, Google, or Azure runs the control plane for you. kubectl is the one remote that talks to any cluster, local or cloud, so your skill transfers everywhere. And you choose by your goal, and A212, local to learn, kubeadm for dev, managed for production. Next class, and A212, pods, the smallest thing you deploy on Kubernetes. One idea at a time. That is your lab, sorted, a free cluster on your laptop, kubectl in your hand, and full permission to experiment without fear. From here, Kubernetes stops being a diagram you look at and becomes a system you operate. So before the next class, go and spin up a cluster, deploy something, and break it in A212. The sooner your hands are on a real cluster, the faster everything ahead will make sense. We will see you in the next class.